Hey, what's up, every student out there that is going to be watching this? So today we're going to be learning a little bit about geometry. This is a continuation of yesterday's lesson. So today is 1.1, part 2. All right. So the first thing we're going to do is get started on this PowerPoint. All right. So it's 1-1 points, lines, and planes. We'll review some of the stuff we did yesterday. All right, so today yesterday we identified and modeled points, lines, and planes, and today we're gonna do more of the modeling. Yesterday was more of the identifying, and then we're gonna identify intersecting lines and planes. So we did undefined term, we did point, line, plane. Collinear was done. Coplanar we're gonna go over a little bit today. Intersection, definition, defined term, space. All right, so hopefully you remember this from yesterday. A point is a location. It has neither shape nor size. A line is made up of points. It has no thickness or width. There's exactly one line through any 2 points. A plane is a flat surface made up of points that extend infinitely in all directions. There's exactly one plane through any 3 points not on the same line. All right, so hopefully you guys are doing well with this, okay? Don't forget, if you have any questions or concerns, to come see Mr. Selby on his Zoom office hours. All right? So, new example for today. Draw and label a figure for the following situation. Plane R contains lines AB and DE, which intersect at point P. Add point C on plane R so that it is not collinear with AB or DE. So this is super duper confusing. If you don't remember any of the stuff from yesterday, which that's quite all right because I feel like it was forever ago, even though it was just yesterday that I filmed it. Go back and rewatch the video from yesterday. Okay, there's nothing wrong with rewatching these videos. I know they can be kind of long, but I mean, it just refreshes. Just keep on doing it. So you want to draw and label a figure for the following situation. So plane R. Okay, so the first thing you want to do is probably draw a plane. Okay. Hey, there it is. Draw a surface, represent plane R, and label it. So normally to symbolize a plane, as you remember from yesterday, we draw a parallelogram, and we write a script letter. Okay. And this, since it's called plane R, we're going to write the script letter as R. Okay. And remember, when it's a plane, it's a capital letter. When it's a line, it's a lowercase. And it's going to contain lines A, B, and D, E. So the first thing we want to do is now draw a line after we've drawn our plane. All right. We want to draw actually 2 lines, but we'll start with 1. So draw a line anywhere on the plane. There's a line. All right. So let's probably call this line AB. Okay. So we'll label it with 2 dots on there and call them point A and point B. So we've got line AB here. Now we need to draw line DE. Okay. And remember, it's got to intersect. Okay. Planes that contain lines AB and DE, which intersect at point P. Okay. So you're drawing this line here. It intersects. Okay. So this intersection here is going to be point P, and we're going to have to label this D and E. Okay. So we labeled it. Now we got to label the intersection, point P. All right. So it looks like we've drawn everything we need to up to this point. Okay. We've got our plane R. We've added lines A, B, and D, E, and made them intersect at point P. All right. Now we need to add point C on plane R. So we need to add point C somewhere on here so that it is not collinear with A, B, or D, E. Now, collinear means that it has to be on the same line. So we know point C has to be on this parallelogram, right? Because it's got to be on the plane R. Okay. But it can't be collinear with A, B, or D, E, which means it can't be on the line of AB. Okay. So you can put it anywhere else except on this line. And that includes even how the line kind of ends here, and it kind of ends here. You can't put a C like right here. You know what I mean? Because hypothetically, this line goes on forever. Okay. And this line too. So you can't put C right here either. You got to put it out here somewhere. All right. And you can't put it on D or E, right? Because it's not collinear with either one. So you can't put it here. You can't put it there. You can't put it there. You can't put it there. Okay. You need to look anywhere else except on that on those lines. So here would be a good place. You could put it here. You could put it here. You could put it all the way out here. You know what I mean? There's a lot of places to put C. So, they put it out here. Draw a dot for point C and plane R such that it will not lie on A, B, and D, E. Label the point. Here it is, point C. Boom. Done. All right, draw and label for the following situation. QR on a coordinate plane contains Q, -2, 4, and R, 4, -4. Add point T so that T is collinear with these points. All right, so I don't know how many of you guys remember what a coordinate plane is from algebra, but it's one of those things where it's like a cross type of thing, but all right, how about I just show you? So draw your coordinate plane and then you want to graph it. All right, so here's the coordinate plane. So you got to graph each point. So QR is -2, so you go over 2, 1, 2, and then you go up 4. 1, 2, 3, 4. So here's where Q is. All right, and then you also want to graph R. So R is 4, -4. So you go over 4, 1, 2, 3, 4, and then you go down 4. 1, 2, 3, 4. So R goes right there. And you might be a little confused, like, Mr. Selby, how did you know which way to go and what to do? So Q is -2, 4. Okay, so the first number always refers to how far over you go. If it's a negative number, when you start here at the origin, you go left. So it's -2. So I'm going to go left. All right, -2, I'm going to go over 2 boxes. 1, 2. If it was positive, I'd go over 2 boxes this way. So it'd be 1, 2. All right, but it's a negative, so we're going to go 1, 2. And then the second number refers to up and down. Okay, and that's 4. So if it's positive, you go up. Okay, and if it's negative, you go down. All right, so we're here at -2. Then we're going to go up 4. 1, 2, 3, 4. -2, 4. And just like for R, we're going to go over 4. But remember, it's positive, so we're going to go over this way. 1, 2, 3, 4. Okay, because that's the first number is +4. And first number always refers to right or left. All right, and then -4, the second number, always refers to up, down. If it's a negative number, you're going to go down. Okay, remember Q had a +4, so we went up. R has a -4, so we go down. All right, then what you want to do is you want to draw a line that connects them. Okay, so draw and label a figure for the following situation. QR, see how it says that there's a line there? When you see that symbol up there, that means that QR is the name of a line. And if we have to draw that after we create our points, we got to draw it. Okay, so let's draw that line. All right, and then add point T so that T is collinear with these points. So as you can see, they drew T on this line, and that's what you have to do. You could put T right here. You could put T right here. You could put T right there. You could put T anywhere on this line. You could even put it right here. You know, anywhere on this line, as long as it's on this line. Okay, and there is an infinite number of places to put it. You could put it here. You could put it here. This looks like 0.6 and then 0.3. But I mean, there's literally infinite. So it just keeps going on forever this way, and it keeps going on forever this way. So, yep, as long as it's on this line, you are good. All right. So choose the best diagram for the relationship. Plane D, okay, contains line A, line M, and line T, with all 3 lines intersecting at point Z. Also, point F is on plane D and is not collinear with any of the 3 given lines. All right, so let's do this thing. So it looks like we've got plane D. All right, does all 3 of these have plane D? Plane D, plane D, plane D, plane D. All right. All right. Then you want to go through and check each one of these and make sure that everything is good on it. All right. So I'm going to stop talking for 5 seconds, and I want you guys to try and pause this and figure out the answer on your own. Okay. And then come back to it. Okay. All right. That was about 5 seconds. Hopefully you figured out what the answer is. Now I'm going to explain how to get the answer. So plane D contains a line. So we already did plane D. All 4 of them have plane D. All right. Contains line A. All right. It looks like they all 3 contain line A, except this one looks like line A is a little off of it, right? Like, as you can see, it's not on plane D. It cuts through plane D. So I would say C does not look to be the correct answer right now. All right, let's make sure the other 3 have line M. 1, 2, 3. Yep, they all have line M. All right, and line T. 1, 2, 3. They all have line T, A, and M right here, these 3. All right. all three lines intersecting at point Z. All right, they intersect the point Z, they intersect the point Z, they intersect the point F. That's no good. All right, so it looks like we're down to A and B. All right, point F is on plane D. Okay, these both have point F. All right, and is not collinear with any of the three given lines. Point F is not collinear with any of the three given lines. This one has point F on line A, which is a given line, all right? And if it's on it, that means it's collinear with it. That's no good. Let's look at this one. F is not on any lines, therefore it is not collinear. Therefore, B has to be our correct answer. And oh yeah, it is. Hopefully you got that answer correct. If you didn't understand the explanation, reach out, all right? Ask for help. All right, draw and label a figure for each relationship. BA on a coordinate plane contains B -3, 2, or -3, -2, and A 3, 2. Also, point M is on the plane and is collinear with these points. All right, so again, I'm going to stop talking for 5 seconds. I want you guys to try and go through this and figure this out on your own. All right, and then play the video and I'll go over it. All right, hopefully you were able to figure out the correct answer. I'm going to go ahead and skip ahead to it. Well, it's A, B, C, or D. Okay. So actually, if you guys want to take another 5 seconds now and see if you can figure out which one it is, make sure that yours matches up to one of these. Okay, let's see where it was. So it was A. All right, let's just double check this here. So draw and label a figure for each relationship. So we've got BA on a coordinate plane. B is -3, -2, and A is 3, 2. So looks like all three of these have BA. All right. B is -3, -2. So you go over 1. Remember, because it's negative, we go to the left, and -3, so we go over 3. 1, 2, 3, and then -2, down 2, 1, 2, -3, -2. Looks like this one's in the correct spot. This one's in the correct spot. This one is not. This one looks like it's at -2, -3. And then this one is also not in the correct spot. Again, -2, -3. All right, so it's -3, -2. All right, and then A is 3, 2. So we have to go over 1, 2, 3 to the right, and then up 1, 2. All right, these both seem correct so far. These are both incorrect so far. So we either know it's A or B. All right. Also, point M is on the plane and collinear with these points. So point M is on both these planes. Is it collinear? On this one it is, because remember, collinear means it's on the same line. On this one, it is not on the same line. It is not collinear. Therefore, A definitely has to be our correct answer. Hopefully you got that one correct. All right, this one is a tough question, and I don't really like this one. It's asking how many planes appear in this figure. And whenever you see these dashes right here, it's kind of saying that it cuts through that. All right, so like AC and ABD is cutting through the plane. All right, BC is on the plane. So this one's a little bit tough. This one's actually two planes. There's plane S right here, and there's plane ABC, which is a plane that these are all on. See how they cut through plane S? They're not technically on plane S. They're cutting through plane S. And that one was kind of like a feisty question. So don't feel too bad if you have trouble with that one. Okay, we definitely won't see any like that on like a quiz or test. All right, that one was kind of like a tricky type of question. I don't know why it's in the PowerPoint. I'll have to switch that for next year. Sorry about that, guys. All right, name 3 points that are collinear. All right, so remember, collinear points are points that are all on the same line. Okay, so there are 3 points that are all on the same line, and those would be A, B, and D. See how they're all on this line right here, line AD? All right, so that means that they are collinear. All right, are points A, B, C, and D coplanar? Explain. Again, this is a dumb question, I think, personally, but maybe there's much better geometry teachers out there that can explain this much more easily. I struggle with it, so maybe it's not a dumb question. Maybe I'm just a dumb teacher. But this is they are coplanar. So coplanar is the same thing as collinear, except instead of two things being on the same line, they're on the same plane. So coplanar, are they on the same plane? And the answer is yes, they are. They're on plane ABC. Okay, right here. So therefore, They are on the same plane. They are coplanar. All right. At what point do DB and CA intersect? All right. So if you see line DB right here, line DB goes all the way up through here, intersects with CA right here. So they intersect right here at point A. All right. A little problem for you. How many planes appear in this figure? Again, a tough question asking about planes when there's only one shown, but how many planes are there? Why don't you guys take a quick guess on this one? All right. If you said that there were two, you were correct. Okay. There's plane T that is shown on here, and then in addition, there's plane ABN. All right. Name 3 points that are collinear. Remember, collinear means that they are on the same line. Okay. 3 points that are on the same line. So why don't you guys take a second, see if you can answer this one on your own. All right. Hopefully you managed to get the answer. It is D. Okay. A, X, and Z are all on the same line. B, O, and X, which spells box, they're not all on the same line. O and X are on a line, and B is not on that line. X, O, N, all X and O are on a line, but N is not on that line. And then there's R, O, B. R and O are on this line. B is not. All right. Our points X, O, and R coplanar. So X, O, and R. You guys take a second, see if you can figure this one out. All right, the answer is yes, they are coplanar. They are collinear as well, XOR. If they're collinear, they are coplanar. All right. At what point do BN and XO intersect? Take a second, see if you can figure this one out. All right, they BO or BN and XO intersect right here at point R. All right. Okay, hopefully you were able to figure out everything that Mr. Selby was talking about today. Remember, if you had any issues or anything, please reach out to me so that way I can help. All right. If you have any questions or concerns, always message me on Schoology, come to office hours, email me, do whatever you need to do to get in contact. I will always try and be available. Hope you guys are staying happy, healthy, and hydrated, and stay safe out there. And hopefully I will see you guys in the classroom again soon. All right. Goodbye.